Are we ready? Make sure phones are away, please. Okie dokie. So we have the last day of August. All right. So Unit 2 is about functions. Anybody know what a function is? Anybody heard of the word function before?
Yeah.
What do we remember or know about a function? Just know that, and I'm not talking about like function is an event, but math. Function is a very specific relation. So we're going to start off with some vocab, and we have a relation is any set of ordered pairs. Okay, so for instance, if I have a set of ordered pairs of like 0, 1, 1, 2, 2, 3, that's what's called in math speak a relation. Please put your phones away. Thank you. Okay. The set of the x coordinates or the input in a relation is called your domain. And the input is always the independent variable. Okay, what you control, just like science, it's what you're controlling to do for your experiment. That's always your x. Time is a perfect example. Okay. The set of your y coordinates or the output in a relation is called, what goes with domain? Range, perfect. And it is always the dependent variable. Because it depends on what input you have. All right? So that's just a general, what's a relation? That's what you're doing when you're doing science experiments. How is something related? Okay? Now, a function is a specific relation where you have each element of your domain. So each element of the domain, that basically means your x, corresponds with each element in the range. So that would be your y value, right? Okay. So basically, every x has exactly one y value. No y is going to repeat. Okay? And one of the way to tell if it's a function or not is with the vertical line test. Okay? And how does a vertical line go? Side to side or up and down? Up and down, absolutely. Okay? So your vertical line is going to run up and down. Okay? So if the vertical line passes through at more than one point, then it's not a function. Okay? So on this example, we have two specific points. And let's just say this is, let's see, 1, 2, 3, and this would be like 1, 2, 3, 4, 5, 6. So this ordered pair would be 3, 6, and this ordered pair would be 3, 3, right? Okay, so I have, x has exactly one y value. I have two different y values. So therefore, it can't be a function. And so what the vertical line test does is it gives you a visual. So if I drew a line here, I got 2 points at the same place. Can't be a function. Okay? With me? All right, so let's kind of see whether or not we have a function or not. if you have a set of ordered pairs, okay, so the rule is that every x has to have one y. So what should we look at? Look at our y's and say, or I mean our x's, and say, oh look, I have two x's that are the same with different y values. So that means what? Can't be a function. Make sense? All right, if I look at my table, I have two y's, but they're coming from different x's, and that's okay. It's okay to have two same y's if different x's. Because if you think about what that's going to look like, if I go over 0 and up 1, and I go over 1 and up 1, my vertical line test is going to prove, you know, I'm only hitting 1 point. Okay? Does that make sense? All right. What about number 4? It is? How do you know? Well, if I draw a line anywhere on here, especially because it's a linear, all linear equations are going to be a function because every x has a completely different y. All right, so there's two ways you know that. Number one, it's linear. And number two, with your vertical, every x only has one y, so it's a function. All right, number 4. What do you think on number 4? It is. Do you agree? Because if I do a vertical line test anywhere, so I agree. Yes, it's a function. Awesome. All right, so now begins the have to tear apart and change around because we have the really weird copier issues. I don't know what happened. Okay. Use the vertical line test. Which graph represents a function? What do you think? A, B, or C? C? All right, if I do a vertical line test anywhere, I only am getting 1 point. So I agree with C. What? Any other ones? Ryan, what do you think? Maybe B. If I do a vertical line test for all of those points, they're all different. So I'd agree with that one. What about A? How do you know? Because you're going to hit 2 different points. So no, we don't like A. Perfect. All right, one of the following graphs shows a relationship where y is a function of x and 1 does not. Okay, what does that mean? That's math speak. What's it mean? Yeah, that's all it's asking. Is it a relationship where y is a function of x? Yeah, so all it's asking is which is a function. Okay? So, draw a vertical line whose equation is x equals 3. So how do you go about doing that? What's the easiest way to do that? Well, where's x equals 3? On your x-axis, right? So there's my point, x equals 3. And now draw a vertical line. All right, so x is equal to 3. And I draw a vertical line. Okay. All right, we did that part. Okay, so give all output values for each graph at the input of 3. So what are you looking for? How are we going to show input and output? Yeah, I need to look at the graph, but how am I going to show it? How am I going to write it? Say that? Yeah, as an ordered pair. Because basically, it's your input and then output, all right? Or just your x, y. So, for relationship A, my x is 3. And where do I have the graph? Well, I have a point here, and I have a point there. So 1, 2, 3, 4. So I have 3, negative 4. And I have 3, 1, 2, 3, 4, 3, 4. All right, when I look at B, I have a point at 3, negative 2. Okay? All right, so explain which of these relationship is a function and why. Which one's a function? B. I agree with that. Okay? How do you know it's a function? Because there's only one ordered pair. Exactly. So when you were in geometry last year and you had to do proofs, how well did you love proofs? Come on, be honest.
I ended up
I hated proofs.
Yeah, there you go. Thank you for being honest. You all hate proofs. Come on, be honest.
half the year, so I didn't get them at all.
That's not good. Yeah, you know, you guys hated them. But you know, what did we just do in A and B? We proved. We just did a proof. That's why you got to learn how to do them to follow the logic. Okay? We proved that B is a function by the definition of a function. And that's only one x can go to one y. See, proofs aren't horrible. Okay, so what are the outputs for the input of x equals negative 2? Okay, given functions defined by the following formulas. What's that asking us to do? What do I always say? Plug and chug. That's all it's asking you to say, right? Because if x is giving you 1, you want your y. So, if we input negative 2 for x, we're going to get negative 3 times negative 2 gives me a positive 6. And so my y is 11. How do I show my answer? Do I just leave it as y equals 11? can. I always like showing it as the ordered pair. You can, but to me, it's since we're doing relations and functions, and it ties the two together. It shows the relation of the two. All right, so if x is -2, we're going to have -4 times -2 squared. What's -2 squared? +4, right? Because two negatives make a positive. And did you know that if you put in your calculator just -2 squared, what's it going to give you back? It's going to give you back your -4 because it follows order of operations, and it's going to square it first and then apply the negative. So if you're squaring in your calculator, you got to put it into parentheses so you get the true sign back. Okay, just a little FYI. All right, anyway, so y equals 1 minus 16, and so y is going to be -15. And we're good with those? All righty. Then, last page of one more definitional stuff. Okay, one-to-one functions. Okay, so this one, we've already determined it's a function. All right, this is a special kind of function. This is a function where one x cannot be another x, and where one y, because f of x is the same as y, cannot be another y. You couldn't have x's the same in the function, but you could have some y's that were the same, right? If it's a one-to-one, there's no duplication anywhere. Everybody matches to their own. All right? So different inputs give different outputs, so no x value will repeat, and no y value will repeat. Okay? Good so far? All right, so let's look at these 4 tables. All right? Let's look and see if we have a one-to-one function. Okay? So, looking at the first table, what do you think? Do we have a one-to-one function? Do we have, we don't, because we have duplicates. All right, we have double duplicates. So we have 2 x's are the same, so it's not one-to-one. What about number 2? I got 2 y's are the same, so it's not one-to-one. What about number 3? Every number is different, so 3 is going to be one-to-one. What about number 4? No, I got double x's, so number 4 can't be a one-to-one. Because, and the other tables are not, we have duplicated x's or y's. Okay. Now, let's look at my 4 graphs. First thing, let's see which 2 are functions. What do you think? 1, 2, 3, or 4? What'd you say? 1 and 4. If I do a vertical line test, I only got 1 point there. Oops. Wow, that one's got 4 points. That's definitely not. Number 3, I'm getting 2 points the same, so that one's not. 1 point, so that one's good. Do you agree with that? Okay, so now I know their functions. Okay? Now the question is, which ones are one-to-one functions? All right? And a one-to-one function, we have the horizontal line test. Okay, just like we did the vertical line test to see if it's a function, that's the first step. Second step, is it one-to-one? And so how are we going to draw the line this time? Horizontally. So, if I draw the line through the first function, I get 2 points that are the same. Is it one-to-one? No, because I'm getting 2 points. So it's not one-to-one. Okay? You with me? All right. If I draw a line through number 4, I'm only getting 1 point. Is that one-to-one? Yep. Okay. So when you're trying to find out if it's like functions or one-to-one and stuff like that, if you get a table, you can look through it and do it. If it's an order pair, sometimes it's easier just to kind of plot your points because then you can do your vertical and horizontal and see real quick. All right? What questions do we have so far? Good. Because we got some easy peasy practices for you. And honestly, let's see. This is you got 15 minutes. You probably should be able to get all of them done in class, and then you won't have any homework over this wonderful 3-day weekend.